Welcome to The Explainer. What if every single tree in a city could become a tiny green money-making machine? It sounds like science fiction, right? Well, today we're breaking down how data science is making that an absolute reality in Manila, turning regular city trees into a valuable source for carbon credits.
So, how in the world did they pull this off? Well, here's our game plan. First, we're going to tackle the impossible math problem they were up against. Then, we'll get into the secret recipe for creating these so-called digital trees. After that, we'll see how they trained an AI apprentice and put it through a super tough final exam. And finally, the best part, we'll see how this all turns into actual cash.
Okay, first up, let's talk about the core challenge here. Why is it so incredibly hard to figure out exactly how much carbon one tree in a bustling city like Manila is actually absorbing?
You might think it's simple, right? A tree is a tree. But we're not talking about a tree in some calm, peaceful forest. This is a street fighter, a survivor that's constantly battling insane city heat and getting hammered by powerful typhoons. And that chaos, it makes all the old, simple formulas totally useless.
And you can really see the difference here. On one side, you've got your happy forest tree, living a predictable life. But on the other, you have its city cousin, which is basically getting cooked by what's called the urban heat island effect and then blasted by typhoons a few times a year. It's this nonstop chaos that just breaks all the standard math.
Now, scientists do have a model that can account for all this stuff. The problem is, it's an absolute beast. They actually call it the monster OD. It's this huge, tangled web of equations. And it's so slow and complicated that using it to calculate carbon credits for every tree, every day, well, it's just not possible. It's what scientists call analytically intractable.
So, if the monster model is way too slow to be practical, what do? Well, you don't try to build a better monster. You get clever. You create a faster, smarter shortcut.
And that solution has a pretty fancy name, Statistical Phenomenology. But all it really means is this: when the real math is too hard, you don't fight it. Instead, you build a digital twin, a super fast AI that basically watches the monster, learns all of its moves, and then gives you the exact same answers, but in a fraction of a second.
And this is the exact 6-step recipe they followed. It's a really clear, logical path, starting with understanding that old, slow model and taking it all the way to the finish line, actually monetizing the carbon credits from their new, fast one.
So, how do you teach an AI to think like a tree scientist? This is where the real magic happens. It's all about building the perfect virtual training ground for this new digital apprentice.
To teach this AI, they didn't just give it a few examples. No way. They built a massive synthetic library, basically a virtual forest, with 100,000 unique digital trees. Each one had its own story, its own combination of age, heat stress, and storm damage.
And this virtual forest was meticulously designed to mirror reality. You can see it included the exact same mix of dominant tree species you'd actually find on the streets of Manila, like mahogany, acacia, and nara. This was crucial to make sure the training data was as realistic and robust as possible.
So just think of this AI model as a really smart apprentice. It sits there and studies every single one of those 100,000 scenarios in the virtual forest over and over until it completely masters the art of carbon calculation. Eventually, it just doesn't need that slow, clunky monster formula at all.
Okay, so the apprentice has been trained, but, how can we be sure we can trust it? How do we know it's actually accurate and not just making lucky guesses? Well, it had to pass a ridiculously tough final exam.
The very first test was maybe the most important. It's called the physics conformity gate. And what that means, in plain English, is they had to prove the AI understood a fundamental rule of nature, that bigger, older trees generally soak up more carbon. It couldn't just memorize answers. It had to understand the why.
So how did it do? Well, it didn't just pass, it totally aced it. On a key accuracy score called R-squared, it hit over 99.8%. The requirement was 95%, so it just blew that out of the water. And it wasn't just accurate, it was also incredibly precise. Its average error was a tiny 1.6%, which is way better than the 3% maximum they were allowing. This proves its predictions are consistently reliable.
But really, it wasn't just one or two tests. They threw the kitchen sink at it. The apprentice was put through a whole gauntlet of 12 different, really demanding checks, testing it against different scenarios and edge cases, and as you can see, it passed every single one with a check mark, proving it's stable and ready for the real world.
All right, so the apprentice has graduated with flying colors. It's been certified. So what? What does this all mean? This is where all that smart data, science, turns into real-world value.
First off, the speed. The new model isn't just a little faster. It is 10,000 times faster than that old monster OD. A calculation that was once impossibly slow can now happen instantly for every single tree in the city.
And remember that tiny 1.6% error rate? That's not just a nice number for a report. That accuracy is the key that unlocks the whole thing. It's what gets it approved by official regulators like Vera, which sets the standards for the carbon market. That's what makes the credits real and tradable.
So what does that look like in dollars and cents? Well, it means a pretty typical urban forestry project, say one with 10,000 trees, could now generate almost $50,000 in revenue. All of a sudden, planting and taking care of city trees isn't just a cost anymore, it's a sustainable investment.
So when you step back, what started as an impossible math problem has turned into this incredibly powerful new tool for cities. But this recipe isn't just about trees in Manila, it's a blueprint. It's a whole new way of thinking about how to solve complex, intractable problems. And that leaves us with a really exciting question. Now that we know we can create a smart digital twin for almost anything, what impossible problem should we solve next?